Hello students, welcome back. We are going to be learning about different types of bonds this week. I just want to start by saying I'm happy that everyone is okay, and I'm really excited to start learning new material again. I know it's been a while, I think about 4 weeks since we last had a new topic, so I hope everyone's ready to get back and started and that we can have a good week. So, the first thing is that we're going to learn 3 different types, but our basics, different types of bonds, is some of the important things to remember is every element wants to be stable. So every element will do anything to form with another one, to bond to another one, to get stable. So our bonds form between elements that are both stable. So, for example, let me read. So that both are stable. So, sorry, let me rephrase that in a different way. So, if, for example, an element is unstable naturally, it's very reactive. That means that it will react with something to form a bond. So everything wants to be stable. And this is how we create compounds. So at the beginning of the year, when we learned about what's the difference between an element and a compound, we said a compound was 2 or more elements chemically bonded. So these are the bonds chemically combined. These are the different bonds that can occur. So we have 3 types. We want to remember where our metals, nonmetals, and metalloids are because it's going to be really important. But our 3 types are ionic, covalent, and metallic. So for ionic bonds, it's usually a metal with a nonmetal. So our metals are over on the left side. We have our staircase, and everything to the left is our metals. Everything to the right is our nonmetals. So just important to remember where they're at because it's going to help us define and understand each type of bond. So our first type of bond, sorry, that is showing up weird. There are some videos, here we go, finally, after loading, that I'm going to link in our description. These both do an amazing job of describing how ionic bonds work, and rather than me just saying what he's going to say, I'm going to have you guys watch his explanation because he does a really good job. But some of the things I want to highlight to really have you guys to remember, and always, if it's underlined, I want you to write it down. But ionic bonds are formed when atoms gain or lose electrons. So they're formed by a metal element and a nonmetal element. And when we think about ionic, it helps me at least to think of ion. So it's even in our name, Ionic. It starts by ion. And when we talked about ions, we talked about those elements that would lose or gain an electron, and it would change their overall charge. So that's exactly what happens in ionic bonding. So a positive ion, for example, a positive ion occurs when we lose an electron, and we call this a cation. And I even have this underlined. So positive ions are cations. Cation is just another term so that instead of saying a big long word of positive cation, we can do a shortened version of cation. And then if a negative ion occurs, when an element gains an electron, it's an anion. So negative ions are anions. So just some new words that we haven't used before with cation and anion, but they're going to be important. And then the big question is, why do these types of bonds form? So the whole explanation is because of electronegativity. So remember, we talked about this when we did the different rankings of things. We talked about electronegativity, which was the measure of how badly elements pull on electrons. So we said that things with a high electronegativity would take electrons or want electrons to be closer to them than other elements. Sorry. Excuse me. So nonmetals will have higher electronegativities than our metals. So for example, when we talked about our periodic table, we talked about things like fluorine, chlorine, things in the top right of our periodic table had the highest electronegativity. So they are going to steal the electron from our metals, which have low electronegativity. So our nonmetals will gain an electron while our metals lose an electron. So another great example of this is, or another explanation is this picture here. So let me first do our bullet points. So every element, we have to remember every element wants 8 total electrons in their valence shell. So elements with 1 valence electron, like sodium, will give it to elements with 7 valence electrons, like chlorine. So we can see that if we just put one more circle, these circles represent our valence electrons, and these squares represent the valence electrons of the sodium. So if we would just put 1 electron from this valence shell into our chlorine would be stable, and then our sodium would also be stable. So what happens is this electron will come over here. We can even see it in our different colors here. This is a square from our sodium, this is a square from our sodium, and it creates 2 separate charges. So we have a positive and a negative, and then because opposite charges attract, we will produce a bond. Our sodium and our chloride will bond to create NaCl. So these words are just a shortened way of saying what I just said. So chlorine will gain 1 electron, creating chlorine minus. Sodium will lose 1 electron, creating sodium plus. And then because opposite charges attract, we will create a NaCl compound. Some common combinations are, when we talked about our periodic table, our alkali metals. So this is our alkali metals with our halogens. So we just showed Na and Cl. Any one of these will very often bond to one of our halogens, any one of our alkali metals, because we have 1 valence electron and 7. 1 plus 7 makes 8. Another example is our alkali earth metals, which have 2 valence electrons, and then this group 16 or 6A, which are also known as our carcinogens. We didn't really learn that, we just learned the numbers. So these have 6 valence electrons, and these have 2. So if you do 2 plus 6, we get to 8. Some common ones to know: NaCl is table salt. We've talked about that. Calcium chloride, CaCl, is rock salt. And then sodium fluoride, so Na and fluorine, is used in toothpaste. I believe this is our last slide. So some common characteristics of ionic bonds or bonding is that they have high melting points, meaning it takes a lot of energy to melt them. So when we have water also has a high melting point. It takes a long time when it's sitting on our stove for it to go from ice. Melting would be going from solid to liquid, so from ice to water. It takes a lot of energy, so they are always also very easily broken, which means brittle. They're very brittle. So, for example, our salt we always find in small little crystals because they like to break rather than stay in one solid piece, maybe like a different kind of metal that we would use as our pot or for our house construction. So that is our ionic bonds. That's all I have for you guys today. If you have any questions, please let me know.